Okay, so we're live with another great set of people to talk to on the enterprise MLOps space. We have Lewis and Leandro, who are the authors of the 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 second edition, I think, of Hugging Face book on the O'Reilly platform and work for Hugging Face. And maybe, Lewis, you want to first introduce yourself to everybody?
Yeah, sure. Thanks a lot for having us, Noah. My name's Lewis, and I'm an engineer in the open source team at Hugging Face. Working in open source at Hugging Face means a lot of different things, but in my case, it's across a couple of libraries. I maintain the ONNX part of Transformers, which is all about exporting transformers for inference. And I also work on an optimum library we have where we can then optimize transformers for different types of hardware.
Great. How about you, Leandro?
Yeah, so I'm also a machine learning engineer in the open source team at Hugging Face. I work mainly on two kind of projects. One is Evaluate, which is an open source library that we're developing, and Evaluate is all about making evaluation of machine learning models like easier and more efficient and more scalable. So that's one aspect of what I'm working on, and I can talk about it more later. And the second thing I'm involved in is more on the side of training models in the space of code generation. Maybe you've heard of like Copilot, that's been now widely used by software engineers, kind of a very fancy autocomplete function where you can code a little bit and it tells you how to complete your function or class. And at Hugging Face, we're working towards like building similar models, but in the open, so people can learn from them, they can play with them, which is a little bit harder for most of the like Copilot models that are like closed source.
Yeah, and in terms of maybe like the technical stuff, maybe we just get right into it because we can. I think there's so many fun things to talk about, and in particular, it seems like one of the things that is probably a good thing to clear up out of the way, because I have a lot of experience with the next generation of people with in ML and data science from teaching. And what I see is that the academic world is still a little bit in the Kaggle mode where you do data science, you do hyperparameter tuning. We show a chart up that says, oh, supervised learning, unsupervised learning, and then it's like, oh, great. And then in a way, what Hugging Face has done has, I guess, completely changed the game, because if you look at transfer learning, there's all these skills that don't really make as much sense anymore. It's not like it's bad to know them. It's like being strong. Like, does it hurt you to be strong? No, it's great. It's great to be strong. But do you need to be strong to be a marathon runner? Probably not. Right. And it's similar, I think, with the transfer learning. It's like, well, now a lot of the stuff that you were doing before maybe doesn't make sense, and you can focus more on like the stuff that Leandro is working on, the evaluate, like, how do we actually get into fine tuning and make it have incredible accuracy, and what are the data sets I should use, how many data sets should I use, do I create my own data set? So it's a lot more on the solution side versus the kind of hand wavy theoretical side. And so I don't know, did anyone have any comments about that? Am I off base, or is that similar to what either of you think?
Do you want to take that,
Yeah,
Leandro?
so sure. So I think like a nice way to look at it is looking at the evolution of like open source libraries at Hugging Face, and it kind of like followed that trend where like the first and most popular library is like Transformers, which is like all about models, like using these models and applying them to your use cases. And kind of like the follow up to that library was datasets, which is a library about like how can we efficiently use data sets, how we can curate data sets, and so on. And like Evaluate is now kind of like the last part in the puzzle, and it shows a little bit the shift in the focus from like people just focusing on models and now going more into the direction of like I mean, even if you have the most advanced model, it still sucks if you train it on bad data. So you should care about your data set, and you should look at your data set, and probably you should spend as much time on your data set as you spend on training fancy models. And then the next step is like, you should also really be careful about what kind of evaluation metrics you use when you evaluate your models. Maybe accuracy isn't like the solution to all classification tasks. You should also look at recall, precision, F1 score, and so on. And maybe do even more like fine-grained analysis of like where your model performs well and bad, such that you know when you go to production that your model is fine. And I think like the academia is very much on like the model side of things, where people are very interested in coming up with a new fancy architectures, like what's the next attention is all you need paper, essentially. Whereas I think if you work in industry, you know that usually the problem is not the model, it's always the data. So I think as the field matures, you can also see that in the open source libraries, and also the mindset of the people changing a bit.
Yeah, maybe just to add another comment there is like transfer learning, I think still the jury's out on that for tabular data. So although we do have, and maybe time series, I think it's still not super clear if, you know, something like pre-trained transformers really make a lot of sense. So I guess a lot of the academic like emphasis on, say, Kaggle mode maybe stems a bit from the sort of old days of, you know, doing tabular regression and things like this, you know, like the Titanic data set and so on. So it is, I think, probably useful to know those skills of things like overfitting and hyperparameter search if you're going to work as a data scientist in a kind of traditional domain. But if you're doing anything with text or computer vision, transfer learning really is, I think, the way to go. And then everything that Leandro said makes tons of sense.
And one of the things I'm doing actually today, in just a little bit, we're going over fine tuning for the Duke graduate data science program, which is called MIDS. And I'm actually getting the goal is by the end of next week that we have the students in class push a fine-tuned model back into Hugging Face so they can create portfolios that show people that they know how to fine-tune models. And do you have any advice for, I guess, people that are trying to make a name for themselves with Hugging Face? Are there certain problems that you would recommend they work on, or skills that they show that, you know, that they're good at? Any thoughts there?
Do you want me
You want to
to
go
start,
first this
Leandro?
time?
Sure. So yeah, I think it depends a little bit on whose attention you're trying to capture to some extent. So I would say like training models today is a little bit commoditized in the sense that partly because of Hugging Face, like the transformers library, it's more or less, let's say, 20 lines of code to train a model. So if you're just starting out, I think that's like a great skill to have. But if you're trying to maybe impress a future employer or something like this, I think a really strong signal is being like a kind of significant contributor to an open source library. And that can be in a range of ways, just, you know, fixing documentation, debugging things, stuff like that. And the reason I say that is because when I'm reviewing applications, especially for people coming out of university, it really helps to get some sort of like public signal of like, okay, this person really gets, you know, open source. They understand the basic principles of like, you know, continuous integration, you know, testing, all that kind of stuff. So if you're looking to sort of ramp up your skills, my recommendation would be to sort of dive into open source. It gives you a full kind of test of all the aspects of software development. And then, of course, augment that by building, I think generally like on the Hugging Face Hub, we have nice demos around spaces. So integrating your model into something like a Streamlit or a Gradio application is then a great thing that you can use in an interview to say, hey, check out what I built. You can actually interact with it.
Yeah, maybe I can add two things to that. So on the one hand, like contributing to open source is like a nice signal on your CV if you say like I contributed to like a popular library. But I think the flip side of that, it's also like a great learning experience, because when you make a PR to like a famous library, your code gets reviewed by like the top software engineers that are out there, right? And you get like feedback from them and you iterate together with them. So even now, I feel like whenever I make a PR, I usually learn something new or look at something in a way that I haven't like considered. And it's for free, essentially, right? You don't have to pay for that learning experience. Of course, you also contribute something. In terms of like what's maybe important when you add something to the hub is something that's kind of underrated, but we see that it has like quite a big impact whether your model gets like popular or not, is like documenting it and filling out like nice model cards and dataset cards. So just pushing a model to the hub is like the first step, but it's kind of like a code repository without a README. If there's nothing to read, probably if I look at that, I don't have a lot of trust that that's a good model, right? If it's just like BERT, I don't know, final, and that's it. But if you add like what was the data it was trained on, what was the setting it was trained on, what are maybe some of the limitations of the model, what works well with it, what works not so well with it, I think that's like an underrated skill. And definitely if you want to make your models and data set popular, we see that there's some correlation in usage and like detail and documentation.
Yeah, those are good. Those are good tips there that are somewhat non-intuitive. That it's a good idea to contribute to open source frameworks because that's going to be a good learning experience. I agree. I mean, that's a pretty good intuition there. Yeah, and I agree with you too that if you don't have documentation for something you're publishing, it's really difficult to know. And it's almost in a way like a perfect signal to see whether a project is even worth your time. Because if someone can't be bothered to document it, maybe it was just like a bad experiment or something, versus if they spent a lot of time documenting it, it in a sense is correlated with the fact that it probably is worth at least looking at because of the documentation. I guess what also comes to mind too is that, and I think I forget who said this, but looking at the classification metrics, it does seem like we're in this world where there isn't necessarily a ton of information about what is the best metric to use for problems. Like, for example, like summarization is something I'm definitely interested in. And I have different kinds of summarization tasks that I'd like to do. Like in some cases, I'd like to do paragraph summarization. I would love to be able to get keywords potentially. I'd love to get, maybe title summarization, so like one sentence summarization. And I'm actually not an expert in it. I just more of the user of it. Is it, if I wanted to build, let's say a fine-tuned model that was customized for each of those three things, which I think are pretty common. I think a lot of people probably care about keywords, one sentence title, and then a paragraph summarization. Are there some ways that you would recommend someone could use Hugging Face and dive into each of those categories and potentially fine tune it, and then when they do push a model, send a signal that says, this is how I solved that problem, and this was the metric I used?
Do you want to take that one, Leandro? Or?
Sure. So yeah, I think one thing that's quite nice is that we have at the moment like a lot of examples for like many tasks. Like so if you want to get started with summarization, we have like a pretty big examples folders even in transformers, where you have like full scripts and training instructions how you could go about it. I think the thing that usually makes you stand out in this thing, because anybody can run like a summarization model now and train it on such a data set, because those scripts are so popular and out there. One thing that can make you stand out is if you work a little bit more and see, like, on the one hand, can you build baselines first? I think that's like, for me, like when I was working as a data scientist, if I saw a project that didn't have like a solid baseline, that was something that would make me like critical of the project. Like you get a score, but you don't have like any relation to that score, right? Is that a really hard task and that's a super good score, or is it a super easy task and it's a a very bad score. So I think baselines is something that can make you stand out. And then also work a little bit more on the data set side and see, can you make your model or your performance better by iterating the way you prepare your data set? Maybe if you have a data set for paragraph summarization, maybe you start training on a much bigger data set that's similar, and then do a second step of fine tuning, or you like add samples to your data set, things like that. I think these are the skills, as you say, like it becomes easier to train a model, but it's also important to continue like investing in knowledge how to make the models even better, especially if it's that simple to do, if that makes sense. And then like in terms of metrics, there's like a lot of work going on at the moment. Like in, for example, in summarization, Rouge is still like a very popular metric, but it has like a lot of shortcomings. People are now trying to get away from it and also come up with like using machine learning models or language models to evaluate like summaries. Like for example, there are things like BERT score, where you can compare to a reference to a reference to like a prediction of your model with like a language model, and see like, is it semantically similar? Things like Rouge, they just look at like, do the exact words appear like in both the generation and the ground truth? And there are many ways how you can like be very bad or very good at it, but not actually producing nice summaries.
I know that there's a graduate student that I was working with that was a TA for several of my classes that's now at Microsoft, and I think he just wrote a paper that talked about how the numbers. I guess I'm really not up to date on a lot of the tokenization problems, but he was mentioning how numbers have been really like an Achilles heel as well, right? Like, so if you try to tokenize a number and it's like the model doesn't understand now the difference between one, ONE and one, right? Like so is that another area that seems like it's under active development?
Yeah.
Yeah,
So
I mean, oh, sorry.
go ahead.
I was going to say, like, I mean, with tokenization, right? It's sort of like a step that we currently have to do with our models to kind of compress the inputs into like a fixed vocabulary. And as far as I know, the sort of maybe like most frontier approach to this is to reduce everything down to bytes. So instead of like worrying about like subwords and these like more kind of grammatical structures that we typically extract in tokenization, if you really think of everything at the byte level, then you're able to do some like kind of fancy stuff where you might combine text with images or even audio and so on. So that's like a sort of maybe like more research level thing. But it is true that in a lot of the enterprise projects that I consult with at Hugging Face, a really common issue is when you're dealing with out of domain like text. So if you're a medical company and you're trying to do say classification of long, doctor reports or something like this, there'll often be a lot of jargon in those reports that, for example, BERT has never seen. And so then what will happen is the tokenizer will split those sort of unknown words into lots and lots of small tokens. And so the amount of information you can actually provide to the model is kind of lost through that tokenization process. And I think that tends to be the kind of like most common challenge that I see in practice with like using pre-trained models and trying to adapt them out of domain.
Yeah, related to that, one thing that also happens, like not only that like words get split into two small pieces, but like these transform models that are now so popular, they have like usually limited context windows, right? There's only so much text you can feed to a model. Like for BERT, it's for example 500 tokens, and you have to make like as much use of those 500 tokens as you can. But if you have a tokenizer that's working on a domain that it wasn't trained on, like Lewis said, in like the biomedical domain, then you have many more tokens for a given word. That means like you also have less information in your context because the information is spread across many, many tokens. So one thing that I think one of the most common requests in these consulting things is like, how can we fit documents that are maybe several pages, or I mean, even like book scale, and we want to classify those. And you don't have like enough context with these models. And one thing you can address this is by having like an efficient tokenizer and make like as much use of the limited context that you have.
Yeah, so those are, I think, some interesting areas that are popping up in in the biomedical in particular. Is an interesting space because I think what's happened with things like Copilot, which I'm a huge fan of. I'm a huge fan of Copilot, and also there's Code Whisper now from AWS, and what I've noticed with those systems is that, at least for me, they make me a lot more productive, and that I'm getting really relevant suggestions, and it's helping me develop things with like write the boilerplate code for me, especially. And I could see with I think medicine, yeah, I don't know when it's going to happen, but it's definitely going to happen, as the same thing will be available to like an orthopedic surgeon, or heart surgeon or something like that, where basically they're, as they're evaluating maybe like a record that the patient gave the doctor, like, I was doing, like, I'll use myself because I have a lot of sports injuries. So, like, the patient was doing martial arts, and they hurt their leg, and then they need to be evaluated for surgery, blah 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 blah. Essentially, given the same kinds of things we're doing with Copilot, it seems like in the very, very near future that there'll be some suggestions like, okay, yeah, you need to like fuse a joint. I would recommend this to the patient with 95%, confidence, right? Or and I do think that that's a very interesting emerging space. I mean, are you getting that as well from you? You both probably have a lot more insight into what is cutting edge from the consulting you're doing.
I mean, one example that's kind of interesting, maybe to briefly touch on, like at Hugging Face, we've been involved in a project called Big Science, where we try to train one of these very large language models, like collaboratively, kind of like a model that's as big as GPT-3. And Lewis and I have been testing it a little bit. It's like a multilingual language model that has like 170 billion parameters. And we've been feeding it like physics abstracts and asked it to summarize it. And like, it doesn't get it always right, but like a few times it came pretty close at giving like a pretty good summary of like a very technical field, right? It's like a physics abstract is not something that you can easily read, even if you studied physics. Like if you're not from the field, it's super hard to grasp. And yeah, it seems like these models are getting closer to that.
And with your with Hugging and Hugging Face, it sounds like one of the things that's pretty cool about both of your jobs is that not only are you building all these awesome, tools for people to use, but you have a consulting part of your company where you're able to work directly with clients, and then that feeds, I'm assuming, back into the product.
Yeah, definitely. I think one of the things that we often get from these engagements are, in some cases, they will then open source either their data sets or their models. I mean, of course, this doesn't happen for like domains like medicine, but we have had some, good collaborations which led to companies, adopting this kind of open mindset. And I think that's like a really nice outcome, because a lot of the like sort of vanilla transformer models that were open sourced by Google and Facebook, they're typically trained on these kind of like academic type corpora. You've got things like Wikipedia, chunks of the internet, and so on. And when companies open source like their own kind of domain, it opens up a lot of new applications. And a really cool one, which happened like today, I think, Runway ML, which is a really cool company using a lot of diffusion models for like video editing, open sourced their like diffusion model for in-painting. So the idea here is you take an image, you can like, select a part of it, and then you can overwrite that part of the image with some text. So you can say, you know, replace the cat with a dog, and it will do that in the image.
Wow.
And I think that's like super cool to see. You know, it's not just the open source community that has to kind of do this work of, you know, open sourcing these models all the time. You've now got companies taking part, and that's for me a very exciting part of these engagements.
And one of the things I think that is going to be interesting that Hugging Face might be involved in, I'm just thinking out loud, is that this whole ethics issue with AI, I think has been slow to build, but eventually will build, and it will. I think one that comes to mind that I think is a very interesting one is the autonomous driving, where I think it's been basically left alone for. It's kind of surprising in a way that it's been so left alone. And I last year I went to Palo Alto to the Tesla AI Day, and I met many of the engineers at Tesla, and they're very brilliant people. I mean, extremely accomplished, and some of the systems they're building are, you know, really impressive systems. But one of the issues that when I was talking to everybody, that I thought about was, well, you know, I think the trolley problem is really does need to be discussed, and just to, you know, bring it up, the trolley problem is, you know, if you're on top of a bridge and you see like the trolley about to hit a family, like if you can flip a lever and it could kill just one person, would you do it? And, you know, it's this whole cultural differences. Some people would kill the one person to save three, but there is no right answer. But with the autonomous vehicle in particular, I think the part that gets a little trickier is if a pedestrian, if you're basically saying I'm gonna save, and you can prove it, like I'm gonna save 100,000 people per year, but we're gonna kill, let's say, an extra 100 pedestrians. That gets a little tricky because the pedestrians didn't agree to that ethical experiment, and so what I wonder is that with things like Hugging Face in particular, if there is more regulation with autonomous vehicles, which I suspect there will be, that if the model does exist, in the data sets exist in some open source form, it makes it a lot easier for the community to agree on what the standards should be. Is that whole ethics issue? Is it something you see even, you know, being in I guess being reflected in your product at all in the future?
Do you want to take that?
So maybe I can go back like to big science. Like I think we have like ethical considerations in like every like project like that we do. And so one very big reason for big science was like there's these very powerful language models like GPT-3, but like people experiment with them, and you can see like they can be very harmful, they can be very racist, and so on, because they have been trained on like random parts of the internet, and they picked up all kinds of like random behavior from these parts. And so the idea of like big science was like we have to like think about these issues, and the best way to do it is not behind closed doors, but as a community, define like values and try to include as many people as possible in the process. So we try to build like a multilingual data set, and we try to include people from each of the languages that we included in the process to define like what's a good data set to include and what's like a bad data set that should be excluded. Nevertheless, even if you like think a lot and hard about like the data set and you spend a lot of time in it, that the model might still have like harmful features. And so there has been like a pretty big group of like lawyers and legal scholars thinking about like how can we make a license for such a model such that we can prevent harmful uses, but at the same time that people can still do useful things with it. And one thing that has come out of the big science project was what's called like the open rail license. Rail stands for responsible AI license. And the idea is that it's essentially an Apache license, so it's open. You can use it for commercial purposes, but it comes with a set of restrictions. So there's several use cases that you're not allowed to use the model for. And the license is also set up in a way that if you create like a derivative model of the original model, that you have to keep that license. So people cannot suddenly like just kind of fork or copy the model, train it a little bit more and say like that's something new, but people have to like keep using that license. And with that, we hope that we can prevent some misuse of these models and develop them in a responsible way. I mentioned that I worked in the code space a bit. We launched like kind of a follow-up of Big Science called Big Code, which is like, can we build a co-pilot type model in the open? And also with code models, there are a lot of like open issues, right, around licensing, for example. It's like if these models are trained on non-permissive licenses, they can produce non-permissive license code. And that's bad for many reasons. But also if you have permissively licensed code and you copy it, you still have sometimes the responsibility to copy also the license, right? Or mention it in some form. And these are like pretty big issues, and we try to think about them and address them in that project. Like I think data governance is like as big of a topic in that project as like the whole training team. So I think thinking about these things earlier rather than later is like an important step to make sure like once you have a model that you can also make sure they're not used for like harmful purposes, and you can develop these core values along the way.
Yeah, I think one of the things that's interesting is if you many people may have remembered the times of the internet when Microsoft was, the bad company, and then Linux was this upstart, and it was this battle, and Linux actually won the battle, and then now Microsoft has Linux embedded into Windows. But I think that wouldn't have happened if there wasn't a credible threat of having open source software. And so the same goes, I think, with machine learning systems and AI systems, is that it seems like the only way that there can be progress made, that this new technology is distributed to everybody in the world, is that there is these alternatives, right? Where whether it's AI pair programming, autonomous vehicles, natural language models, that these are all essentially like ways to keep proprietary companies in check, right? Because if you don't have a credible alternative, then they can basically do whatever they want. And I'm probably a little more aggressive towards regulating capitalism than the average person, but I'm actually not a fan of unregulated capitalism. I think America, if you look at it from 1940 to current, it's not been great for the world. Actually, I think the quality of life in America is a pretty good example, where it's actually one of the lowest life expectancies in the world for G7 or G20 companies. And you could definitely say some of that is maybe there's unregulated capitalism. So I do like this idea of maybe there's that's one of the reasons why people should support a company like Hugging Face, is that it actually is creating products in a way out in the open that actually helps, and essentially like regulate capitalism.
Yeah, maybe one thing to add to that is a large part of sort of the platform and the community around Hugging Face. It's about trying to set kind of norms. And I sort of personally am quite pessimistic about regulation, like legal regulation, ever keeping up with developments or recent developments in ML. Because just from personal experience as an engineer, keeping up with the engineering side of things is its own challenge. I mean, there are these plots showing that the number of papers per year is growing kind of like super exponentially in the field, and the amount of compute that's being used is growing kind of exponentially. So I feel that legally it was going to be kind of hard to have laws that will keep up with like the next thing, because it's always sort of far ahead of the curve. And an alternative is to try and kind of encourage people to adopt certain kinds of behaviors which are roughly aligned with, however we define responsible. And what Leandro mentioned earlier about model cards and dataset cards is a part of that, where you document your model and your dataset, not just because you want it to be used and all those kind of good things, but also so that people know that there, may be some inherent limitations of your model, or maybe you shouldn't use your model in some, specific use case, as Leandro mentioned. So this is all kind of integrated both from the science side, but also on the product side. And we do implement various features on the hub that try to kind of, guide a little bit these decisions. And the most recent one is around, stable diffusion, where you have a model that can generate, realistic images from text. But many of these images can be pornographic or, worse. And so having a mechanism that kind of tries to encourage people to both use a safety kind of checker, but also agree to some kind of very strict conditions of using the model is like a way of kind of, sort of setting the ball rolling in that path. But I don't know. I think it remains to be seen. It's not super clear to me what will happen in 1 or 2 years' time, whether it's fully regulated and like pharma, or whether we're just in the Wild West as we kind of are today.
Well, I think there's also
go ahead.
Another thing, like an advantage of building these things in the open as opposed to like behind closed doors in some like special labs at big companies. Like if you look at the very early days of transformers with like BERT and GPT and so on, it was very open, and the labs open or released the models. And I think that's very fruitful for research because people can build on top of that, right? So a researcher can go take BERT, modify it a bit, or fine tune it on something and see how it performs and investigate it. But if you want to do the same thing at the moment for Copilot, you first need the resources to train a Copilot type model, which is like not cheap. So, and you actually don't know how it was trained. So you're never 100% sure that you replicated like the type of model that you want to investigate. And that's just the first step that you need to do to build on top of that kind of research. So I think if at least like maybe very product specific models companies don't want to release, but at least like these more fundamental models, when they're released, I think that accelerates research and in the end benefits like everybody because the progress is faster.
Yeah, I think that's a very good point. And as an American, there is this every country's got their annoyances, and one of the things I'm annoyed about with America's culture is this idea that all innovation comes from American corporations and that they solve all the problems in the world. And I mean, at least that's there is a little bit of that in America, is like we're number one, right? But to your point, I think the issue with that approach is that if people can't evaluate why you're number one, then are you number one, right? And so with recommendation engines, I think are another one that are like I say, recommendation engine and autonomous vehicle are two that are pretty interesting because in both cases there's a lot of academic research in there, but then it seems like a lot of the top people got hired to work in industry, and then now two of the bigger problems ethically in AI happen to be around both of those products, right? Like I think now non-Americans are probably going to think about things very different than Americans, but a lot of non-Americans that I've been around, and I've lived outside of America, are a lot of times, I think, a lot wiser about limiting the power of American corporations, and in particular the social media companies in America that have essentially gone unchecked with the recommendation engines, and we don't really know all of the details of like YouTube recommendations or Facebook feed recommendations. I actually used to run a social media company in 2013 to 2016, but sports. So it was a sports social media company. And so I have some experience with the complexities of a recommendation engine at scale and all that stuff. But I think the issue there is that if it was developed, let's say in Hugging Face in the open, a recommendation, and there was actually some evaluation metrics that actually showed that certain kinds of recommendations, and maybe even you invent a word for it, are toxic, and they actually create, clear negative externalities to the world. I think we can think of a few, like overthrowing democracies would be one. Like there's a metric that's like, probability of overthrowing democracy with but like I think that would be one. And then also the autonomous vehicle. So I think it's an interesting way of without getting into legal situations. If more and more stuff is developed maybe in Hugging Face, then potentially that itself could help solve some of the issues that we're having with technology.
Yeah, I think, for example, recommendation engines are like a good example of like needing to be careful what metric you choose and what you optimize for. It's like, I think many like recommendation engines are tuned to like optimize for as much attention from a consumer as possible. So if you're YouTube, you want to make sure people stay on your platform and they watch as many videos as possible. And so if you optimize for that, right, like being controversial is one thing. You can get like viewers' attention, and if you just keep optimizing, you might get an outcome that's it optimized like attention, but probably at some like pretty bad side effects. It's kind of like the paperclip problem where you say, I want to have a good paperclip factory, and in the limit, it's like everything in the universe is now paperclip. And I think it shows like how important it is to choose metrics that reflect your values in a sense. You probably don't want to optimize just for one thing. You probably want to trade off several things. And I think that's like a very hard skill to learn, but like a very important one if you build like machine learning systems.
Well, there's that expression, I think was it Steve Jobs that said that a computer is a bicycle for the mind, which is kind of a catchy and I think useful analogy, because you're saying that it's actually enhancing your core capabilities. Now I think you can make the argument now, and I don't know what you would call recommendations engines, but they're definitely not a bicycle for the mind. You could say that they're like I don't know, like a heroin habit, or or some really toxic thing that degrades essentially, where a computer that does spreadsheets and lets you program is a bicycle for the mind. But a lot of the technology that's been developed the last 10 years or so, or 10, 20 years, like especially in the social media space, is actually degrading the human mind, right? And in fact, potentially hurting IQ, memory, health. And I think if you were able to, let's say someone decided to build a recommendation engine and put it onto Hugging Face, and then they actually were able to clearly say why their recommendation engine was better than YouTube's or better than Meta's, and here's all the metrics, that I think that would be one way you could really lead by example. Which, so I think you're I've never really thought about it until you brought it up about this, building the systems in in public view. But I think it could really be one of the solutions to some of the real problems the world has.
I guess in that specific case, the big open challenge is the data, because as far as I know, all the recommendation engines really rely on in-house, customer data. So, with language models, we're able to just kind of train on internet dumps. But I think that would be probably the real challenge, is figuring out how you can build something that is useful and also open. Not impossible, but probably.
Yeah, so
probably
maybe one of these companies will do that, right? Maybe they'll put the data onto Hugging Face. That would be great. So a few things, since we're getting close to the top of the hour, that I'll bring up now, is that I was reading through your book on O'Reilly platform, and it really is a great resource for people that want to know about Hugging Face and to understand like what a transformer is and why it's different and how to fine tune models, and there's also a link to the source code for the book as well, and it looks like there's it's even being updated. Do either of you want to talk a little bit about your process with writing the book, and maybe recommendations for people that want to use it to build stuff and push it to Hugging Face?
Do you want to take that, Leandro?
Sure. So I think, not to advertise too much, but I think we've been like very lucky with O'Reilly. I think they've been like a great partner for writing the book, in the sense that we were able to write the whole book as notebooks. So every chapter that you see is essentially like a Jupyter notebook, where like the text in the book is just markdown cells, and like the code is just a code cell. And I think that has been like a very like rewarding experience writing a book that way, especially like an applied programming book, because you have your code next to your text and you can iterate quickly on both of them. I think if you decouple those two, it gets very annoying, where you have to like make the script to run and maybe do what you want, and then you have to write the text in another place, and then you figure out, oh, you need to change something. So that has been like very nice. The second thing about updating the resources, so we were allowed to release all the code of the book. So all like the code cells, we weren't allowed to open source like all the text cells too, because that would essentially be the whole book. But all the notebooks with the code are available. And as you say, like the things are evolving pretty quickly. I think we picked not such a bad time to write a book about transformers, because it has become pretty stable. So most of the things that are in the book are still up to date. But there are libraries that got updated, and we've been, for example, working with the folks at Haystack to write a chapter on like question answering at scale, where you can question answer essentially on like whole documents or databases. And they wrote a cool tool for that, and we integrate that in the book. And they did like a release of a new tool, and they were like nice enough to also update the chapter. So in the repository of the book, we added like a new version of that chapter, where you can now look at how that's done with the new API. We've also had a colleague who worked on more on the AWS side, and he was really excited to see like how can you do the things we do in the book with like the AWS ecosystem. And we now have a folder in the repository where you can essentially see the translated chapters, some of them, not all of them yet, with SageMaker. So how people who maybe live in that ecosystem can use those tools. And I think I really enjoy having the book kind of as a living thing, where you can update it, extend it, and like the main text of the book is still valid, but on the code side, you can extend it with like new tools and new things to work on it. Anything you want to add, Lewis?
Maybe an interesting one was when we were writing the book, we weren't sure if it was going to be out of date by the time it was published. And I think we were quite lucky with the timing of things, because, shortly after the book came out, you started seeing this like huge amount of interest in things like, okay, so diffusion models more recently, but also in like, speech models and stuff like this. And I think we never would have finished the book if we had, waited a bit longer. So we were kind of lucky that we got in just before the whole large language model revolution started taking off. And that's maybe an interesting lesson. I think like writing about a domain that's moving very fast is quite a risk, because it took us about 1.5 years to write the book. And, in that time, in machine learning time, it's, almost a lifetime. So
Yeah,
for anyone who wants to write a book, be careful.
Yeah, I wrote a book called Practical MLOps just 2 years ago, and just looking at it, I'm like, wow, a lot of stuff changed, like there just weren't available at the time. And I think what is nice about the approach you used, which is that there's a living repository. It means that even if there is a sample that's like a little bit different, who cares? Just go to the notebook and run the code. And then also it means that whenever there's a need for a new version and things start to stabilize, it shouldn't be that difficult to make updates to the book in the future. So yeah, I found it very, very helpful to read through the book and run through some of the code. And one of the things that's changed, even again, this stuff is changing so quickly, is that I think it's just been in the last year, there's now 3 credible places to do GPU. Just recently, it was only like Colab, right? And Colab, there's a lot of nice things about Colab, and I've been a huge fan of it from the very beginning. But if you wanted to get like, do some of the things like that are covered in your book, for example, maybe you want like a pretty beefy GPU. And I would say a lot of people don't have access to a GPU for many reasons. Even if they had the money for a $5,000 GPU during COVID, like you couldn't get one, right? Like they're. So what's happened in the last year that's pretty fascinating is that SageMaker Studio Lab, which is in kind of a limited release, that's actually been a kind of a game changer. And so people could take your notebooks and they could just run it in SageMaker Studio Lab. And then the one that's really new that I'm using, like in fact today in class at Duke, is the GitHub Codespaces GPU. And wow, I mean, now you can do some of the fine tuning, and it's just lightning fast with in particular, I think GitHub Codespaces with GPU. And has that been something that has been on your radar? These new, more public-facing GPU execution environments.
I think, at least for my personal experience, I've generally used Colab primarily, and also in the book, I actually wrote a lot of it in Paperspace. They have quite a nice experience for working with notebooks. But I agree with you that now, for me, my personal preference is using Codespaces. I find VS Code, for me, completely changed the way I program. I used to have all these different IDEs like PyCharm for Python, and then something for Java and blah, blah, blah. And with I think VS Code, they've more or less, unified all the languages in one place, which is really nice. And then once you're used to VS Code, then Codespaces is also really cool, right? So you just push a button and boom, you've now got something running. I don't know about Leandro, if you have a slightly different workflow.
Yeah, I mean, so in terms of like these public platforms, I mean, one thing that I think were kind of careful about was making sure that all these chapters, they run on like Colab, because we wanted to make them accessible and that people can run them for free. I think like if you're in the fine tuning space, like that's fine. Like if you want to take a model, you want to fine tune it for your domain, usually you're pretty good if you have access on one of these public GPUs. And I think that's like the most empowering thing. An interesting trend on like the other extreme is like when you want to like pre-train models, which is kind of what I'm doing nowadays a little bit more with like these code models, is it went from people being like in awe because somebody trained a model for 2 weeks on 8 GPUs, and people thought like, oh, that's like so much compute, to now like the big science model was trained for 3 months on 400 GPUs. Wow. So like the scale is like exploding, and you see like Facebook or Meta buying like new data centers with like thousands of GPUs to train these ever growing models. So I think that reflects again that it's important to like build some of those models in the open, because nobody or not everybody has access to like that kind of compute that's necessary for these endeavors.
Yeah, I know in the United States there are some government funded facilities that have huge GPU clusters. I think one of them is in Tennessee, actually. I went there it's Oak Ridge has a huge amount of GPUs. I don't know how many they have, and a lot of the film companies as well. I used to work in film. They have a lot of they called them render farms back in the day, and that might be an interesting place for people to dive into. Is I don't know if some of these people that have farms of GPUs are going to let people train LLMs on them, but it's an interesting space. I mean, I think yeah, it seems like there's those are the two directions, is that if you have access to a bunch of GPUs, doing the big training jobs is obviously useful. But I would say probably 99% of people are probably more interested in the fine tuning, and for that, I think the GitHub code spaces for now, I think it's good that there's competition, is currently in the lead. Like first it was Colab was just amazing, and now there's SageMaker Studio Lab, which is pretty good, and then there's now and then the GPUs from GitHub Codespaces. So it seems like we could be in 2023. My guess is that we're going to see a bunch of competition for the public GPUs, where the workspace becomes actually cloud only. Where why would you even care about having an expensive computer anymore? It's in fact, it solves some problems. Like, yeah, if you're an advanced practitioner, being able to shell into a cluster and run a bunch of things is obviously useful. But for many people that don't have those skills to SSH into clusters and spin them up and monitor them, a cloud-based workspace that's pre-configured for you, that maybe has like all of the deep learning libraries and everything set up, it really could kind of tip the scale towards more and more innovation happening for a platform like Hugging Face. So I'm pretty optimistic that combination of like Hugging Face plus things like GitHub Codespaces could be very interesting.
Yeah, I also think
sorry.
Just to add a short note, like for me, the platforms that I currently like, I'm mostly on GCP, on Google Cloud these days, mainly because like it's nice that you can quickly scale up. So most of the time, like developing, I'm also fine just having one GPU, or maybe sometimes not even a GPU. But then maybe once you're ready, you know like what you want to train. And if you have like 4 GPUs or 8 GPUs, you're just 4 or 8 times faster, right? At kind of the same price for the whole training, because you add cost because you add more GPUs, but you're as much faster essentially. So it improves in essentially your iteration cycle, which is I think always a good thing. So I think like if these platforms can manage to bridge that gap too, so that you can easily scale there, that you can say like, now I'm ready, I need like 100 CPUs, or I need 200 GPUs, or maybe less than that, but that you can scale within like the same environment. I think that's like that will be like,
yeah, that's a good point. Yeah, I mean, I think that it wouldn't be that tricky, especially for a company like GitHub, to basically just, there's a toggle you would hit, like maybe an environmental variable that says how many GPUs you want, and then it just gives you more.
Yeah.
Great. Well, I really appreciated your time and learning more about the Hugging Face ecosystem and talking about your book. And I hope people get a chance to read it. I mean, really, I would say it's probably one of the best possible places to learn about Hugging Face outside of the official Hugging Face documentation. So people should get a copy of it. Do you want to mention what the name of it is again? It's
I don't know if we can see it.
Yeah.
I've got the stupid background on, but it's let me just take this off. So there we go. It's natural language processing with transformers, and the reason you should buy it is because of the beautiful bird on the cover. So I don't know, what animals did you get, Noah, in your O'Reilly book?
I got like a snake before. I've had a like a dog before. But yeah, bird, that's a and it's colored as well, which is pretty awesome. And your book
Yeah.
is doing really well, right? Isn't it like a best-selling book? Like, so yeah, it's the community has decided it's a good book. I read it. It's a very good book, and definitely would recommend people pick up a copy of it.
Excellent.
Okay, well, thank you all. I got to go teach. I appreciate it. I'm sure we'll talk again. But
Thanks a
nice.
lot for having us.
Okay, bye.
Bye, Noah.
Bye.